Hello, good afternoon. Welcome to Ham Radio 2.0, live from the Ham Shack. My name is Jason, and my call sign is Kilo Charlie 5 Hotel Whiskey Bravo. Thank you for watching this episode of Ham Radio 2.0. This is going to be HamCom 2016 forum on 630 meters, the use of 630 meters in the amateur radio band. 630 meters is like, gosh, I don't even remember the frequency on it right now, but it's below the AM broadcast band, which is around 1,000 kilohertz, so like 1 megahertz. So I think it's somewhere down in like the 700 kilohertz range, something like that. I don't remember. But it's cool. The gentleman who gives this presentation has given this presentation at several club events that I attended one of them. I wasn't able to stay for the whole thing, but I listened to the first half of it. I think it was. And when I saw that he was presenting at HamCom, I emailed him and I said, "Hey, do you mind if I video record your presentation?" And he's like, "No, not at all. That sounds great." So he allowed me to do that. So I thank him for that. And he's done a lot of research and a lot of activity on the 630 meter band, which is not. There's some kind of like experimental license you got to get to be able to transmit on it, but they're working with ARRL to get it licensed for everybody, so that it's an actual officially added amateur radio band. So let's take a look at this video. Thank you for watching. Check out my other videos from HamCom 2016. This will be the first of about 4 different videos, so stay tuned right here. Thanks for watching.
What I'm going to give you today is basically a 50-cent tour. I'm not going to go into a lot of details. It's really going to be an introduction to kind of give you an idea of what we do, what's going on down below the AM broadcast band, and really to kind of give you some hints about what you could do to be able to be involved in operating at 472. So without ado, one other question. Can I see a show of hands if you've seen one of my talks on this topic in the past, whether it be at HamCom, another club meeting? Okay, great. Now for those of you that did not raise your hands, can I see a show of hands if you have at least heard something about 630 meters? Okay, perfect. Okay, well let's go ahead and get started here. Now there really is, let's make sure this is running, there really is quite a bit going on down below the AM broadcast band. In fact, this diagram really doesn't even do it justice. 490, 518, you've got these maritime navigational reports that are sent by way of a mode that's very similar to RTTY. It's called Navtex. Down at the bottom of the band at 60 kilohertz, you've got WWVB. So if you happen to have one of those neat atomic clocks that sets itself, that's the signal it's using right there. 137 kilohertz is another one of the bands that's really in play through this process of trying to acquire these bands. And then you've got the navigation beacons here. And these right here are generally used by aviation. They're modulated CW. They're transmitted for the purpose of giving people bearings to various airports and identifying airports. These are actually very useful when testing antenna systems, receive antenna systems and whatnot. Unfortunately, as many of them are failing, they're not being repaired, they're being replaced by other technologies that are available. And then we have this chunk of spectrum, 472 to 479, and this right here is what we're going to focus on today, 630 meter band. Now, wrong direction. Now, oftentimes when people think of these bands below the AM broadcast band, we're thinking of very tall towers that are used as radiators with insulated bases, maybe some top loading, guy wires that maybe are insulated, maybe we're sitting next to saltwater marshes, coastal lands. Well, fortunately for amateurs, we can still find a significant amount of success with significantly more simple systems. Now, there are a lot of common perceptions in the amateur community about what goes on 630 meters. A lot of people will say that 7 kilohertz, you really can't do much with it. You know, if you're an AM guy, you're probably right. You know, for a lot of the things that people operate on this band, it's probably going to be just fine. Another comment we get about is the power. We expect to have a 5 watt EIRP limit, and a lot of people say, well, what are you going to be able to do with that? Man-made noise is certainly an issue, and a lot of people talk about man-made noise, and of course the low-band operators already know really what that entails. Get a lot of guys that talk about effective antennas on a city lot, and that's a very big deal and certainly a very realistic consideration. And then the other option is, or the other comment is, no amateur equipment transmits on 630 meters. Fortunately, none of this is true. Now, who do we typically deal with when we're dealing with 630 meters? Well, we get a lot of what I refer to as extreme operators. These are guys that they like digging in the noise. They like looking for signals. They're low band ops, for example. We get a lot of guys that are used to listening to signals that may be below the noise floor. And we get a lot of EME guys, okay? A lot of EME guys, a lot of microwave ops, point-to-point, weak signal guys. And of course you get QRPers, guys that are used to running low power. We get a lot of experimenters. And in fact get a lot of guys operating, testing a variety of antennas. In fact, I'm going to step over here and click this for just a moment. I probably need to rethink the location of this mouse. Back in January of 2014, I did a study, very non-scientific study, of what amateurs might expect as far as success on 630 meters using very simple antenna systems. I'll tell you, the smallest antenna that I tested was an 8-foot tall piece of pipe, base loaded over what would have been a relatively good radial system on 40 meters, but probably a pretty lousy system on 630 meters. I fed it with 100 watts TPO, and I didn't melt any coils, I didn't create any fire, I didn't start any fires to begin with, which is a good thing. And I was actually heard by guys in New England at levels that were consistent with operating JT9. Now, keep in mind, this was just a snapshot in time, single opportunity to be on for this one night that I did this particular test with this antenna, but I was able to find some success. And it was through that experiment that I think a lot of guys can find hope that maybe are in situations that they cannot otherwise operate at these frequencies.
Sir?
Yes, sir.
Back in the 1980s, I was out west working with a lot of guys on the 1,750 meter hobby band.
Mm-hmm.
Our antennas there are about 400ths of a 1% of
That's
the
right.
size that you can have. We were limited to 1 watt
Right.
at the base.
Yep.
The effective radiated power was in the microwatts.
Yep.
And in the late 80s, we broke 1,000 miles.
Yep.
Then we broke 2,000 miles. Then we worked from California to Hawaii.
And that's a very good point to make, because a lot of people don't realize you don't need a tremendous amount of power to be effective at these frequencies, and that's a perfect testament and example. We also get a lot of propagation experimenters, a lot of guys like Jim Hollander, W5EST, who have developed a lot of these models to describe much of the behavior of the band that he has observed over the last couple of years. Now, there is a lot of room for modulation technique experimenters. You know, we're in a day and age where digital radio is kind of becoming the norm, and guys are talking about digital voice modes and things like that. Well, there might be an opportunity for phone operators if they wanted to develop digital voice modes at these frequencies that were very narrow. Certainly for would-be programmers, that's a very interesting challenge ahead, because when you're dealing with 7 kilohertz, you're not dealing with much room to put a normal 2.4 kilohertz sideband signal. It really kind of creates some complications. Now, we do get a lot of home brewers. That's not to say that you can in fact buy equipment, but a lot of guys like to build their own stuff, and it's part of the challenge. Now, I happen to believe there's a public service potential with 630 meters in the form of digital modes and point-to-point communications. In this area, I've seen a number of groups that are using, I think, some FLDigi mode on repeaters and whatnot to communicate for part of their HamCom training. And my thought is, what if you could do that same thing without the intermediary infrastructure? You had the repeater out of the way, but yet you could cover several hundred miles on ground wave. Okay, now 630 meters has a combination of both very good ground wave and very good sky wave. But in this particular case with the ground wave, imagine being in a situation where you're unaffected by solar conditions or EMP conditions. And part of that ground wave, let me see if I can come over here and do this again, has to do with the ground conditions in the North Texas area. We live in what's known as the Blackland Prairie. And in this area, the average ground conditions, at least the area, I live down here at this little green splotch, and the average ground conditions in this area are about 30 millisiemens per meter, which represent really the best ground conditions, or best average ground conditions anywhere in the country. Okay, so we're really in vertical country here, and that's a very good situation to be in. Now the guys that are down here on the bottom side of the escarpment that are at 15, you're probably in the 80 to 85% as far as being how good you are compared to the rest of the country. So, you know, if you're at 15, don't panic, because this is still really good average ground conditions. And you may be at 30 in some of these places, given that it is, in fact, an average. Let me see here. Come over and click this. Okay. Now, as far as modes are concerned, it's really going to be a digital and CW band, okay? CW requires neg 10 to neg 13 dB signal to noise in a 500 hertz bandwidth for really to be able to have an aural normal CW QSO. Now this is not talking about QRSS modes, okay? QRSS modes go very, very low below the noise floor. We're talking about just a normal rag shoe type QSO. Now, JT9 has become very popular, and I tend to believe that JT9 will be the de facto QSO mode until something better comes out on 630 meters. Just a couple of months ago, I completed a QSO with Merv Schweigert, K9FD/KH6, who operates as WH2XCR, and this QSO represents the first QSO between Hawaii and anywhere on 630 meters, and we did it using JT9. Got a few more anecdotes about that a little bit later, but it really is a fantastic mode for operating below the noise floor. A lot of us operate whisper, which I refer to as an idling mode. Now, an idling mode in this case is, well, what are your radios doing right now? You're all here, your radios are sitting idle at the house. Well, mine stays running with whisper, generating a signal on a fairly regular basis that's picked up by receive stations around the country and around the world. And from this information, people can do first of all, determine, you know, how is the band doing at any given time. And number two, they can do things like propagation reports, propagation studying, or study propagation in terms of a variety of different factors, and Whisper is a really good way to do this. I'm a big fan of Whisper whenever I'm not looking for QSOs. Now, Domino EX, specifically the FL Digi version, is a good keyboard-to-keyboard mode. It looks very similar to what you would do with PSK31 as far as operating, but it's an FSK mode. And it's actually a very good mode at a number of bandwidths and number of speeds. Now, GMSK is Gaussian minimum shift keying, and that's really only available in the program MMVary. If you're familiar with the program MMTTY for RTTY, these are the same guys. Now, GMSK is, like I said, Gaussian minimum shift keying, and it in many ways is very similar to Domino EX. But in many cases it has a better detection limit, slightly lower, probably in the low neg 20s is a good limit. Few of us have played around with RTTY. You know, this is really intended to be a QRO mode, so you really have to have nice band conditions for that to happen. PSK31. We get a couple of guys that play with that from time to time, but the real limitation there is that it requires a linear amplifier. And most of us on this band are running switch mode amplifiers at very high efficiency. Generally speaking, MSK is at the top of the food chain, followed by FSK, and then down here someplace is PSK 31, or PSK in general, regardless of the bandwidth. So you don't get a lot of PSK, but in the future you probably will, particularly as more linear amplifiers become available. Now, I have kind of a question mark next to SSB. The ARRL, in their comment on the notice of proposed rulemaking about the creation of these bands, recommended it says 2.1, it should be 2.4 kilohertz bandwidth limit, which would allow phone activity. It would primarily, in my opinion, be a regional daytime band. In the past, there have been guys that have successfully operated phone on 630 meters, or actually 600 meters. But they're running significantly more power than most guys have, and they were really more regional in nature, guys up in the Northeast. So it remains to be seen how effective that may end up being. Now, I get a lot of questions, and this one's kind of a head scratcher for me, because people say, what does the band sound like? And I kind of have to think about that. What does that really mean? Well, seasonally, the band changes. Sometimes you have very noisy conditions during this time of the year in the summer, and then you get into winter and the band sounds like it has a noise floor like 10 meters, where it's around S0, S1 on the transmit vertical. And that's pretty remarkable. So this is a recording by Steve Johnston, WDAS, of me calling CQ just a couple of years ago. Steve will be one of our presenters tomorrow, but as you'll hear in just a moment, it's an armchair copy signal. I'm in the clear, he's in Wisconsin, I'm here in Texas, and it's perfectly readable, perfectly copyable, and Steve is simply using his transmit antenna. He's not using any specialized receive antennas to be able to copy me during this session. So I guess it really depends on the band conditions that you're encountering at the time as to what the band really sounds like. Now, last April, the FCC issued ET 1599, which was a notice of proposed rulemaking to dispense with the final acts of WRC 07, which 630 meters was a part of. Now, one of the big key facts is that the FCC believes that amateurs can coexist with existing services, and that's a big thing, because this is really kind of their idea, you know. And that being said, I think, you know, that's really kind of propelling us ahead in this process. We really only had one opponent, which was the Utilities Telecommunications Council, formerly the Utilities Telecommunications Council. Now they're known the Utilities Technology Council. And their concern was power line carrier systems that coexist in the region between 9 kilohertz and 490 kilohertz. Now, the reality about all of this is there is no active power line carrier equipment in use above 300 kilohertz today, anywhere in the lower 48, okay? In fact, we've had a couple of guys that were professional engineers that had done some implementations on these systems at a variety of sites around the country and said there's nothing above 100 kilohertz. So the reality is most of it that exists is probably around 50 kilohertz or so, and there's not much left. It's all transitioning to fiber-based systems. So not really an issue there. Amateurs did a really good job coming out of the woodwork to make comments on the proposal. In fact, the Office of Engineering and Technology was really kind of surprised and taken aback by the number of people that were really interested in this band. They don't normally get this number of comments for things that affect HF. So it was really put us in a good situation. Where we're at right now, rules establishment is in progress for the band, and I think I reported last year that my sources within OET were saying that they would begin working on this in the second quarter of 2016, and we're there, and that apparently is in fact the case based on what's going on. When will they be done? That's not for anybody to decide but them. You know how these bureaucratic situations can go. But I do feel pretty confident that all of this is going to go through and be okay. Now, where do I start? Most people, I tell them to start with what can your receiver do? What can you hear with what you've got? Don't run out and do anything special just yet. What can you hear? So most HF rigs have general coverage receivers anymore, and they generally receive okay. A lot of HF rigs with general coverage receivers will have an attenuator that kicks in below 160 meters to protect from broadcast station overload. But in many cases, that can be a feature because it can actually improve your signal to noise ratio, and that's not always necessarily a bad thing. Receive converters are actually very good. In fact, the receive converter that, in my opinion, is really very, very good is the Jackson Harbor Press receive converter. The system with the extra set of filters will cost you $22 total. And if you accidentally, if you don't have a receive only port on your rig and you're using your primary transmitter port, the mixer here, if you happen to burn it up because you transmit into it, is very, very cheap to replace. So you're in good shape if you have a mishap. What these essentially do is up convert. They take signals from basically the low frequency and medium frequency range, and they convert them up into a frequency range that your HF rig can actually work pretty well. Typically the 30 meter band, sometimes in the 80 meter band. But this is a good way to do it if you don't have a general coverage receiver or your general coverage receiver is not up to snuff. Now, the K3S, the K3 with the synthesizer upgrade, all of the Kenwoods, the newer Flex rigs, Soft Rock Ensemble 2, all of these have really pretty good receivers in them at 472 and can do a good job directly reading out and allowing you to hear the signals on this band. You get a lot of military receivers and boat anchors as well that tend to turn up a lot of old airplane radios. Those are fine for CW and phone. In my opinion, they don't have the frequency resolution for the digital modes, and they don't have the frequency stability to be able to work well at those frequencies or for those particular modes. You also run into guys that have selective level meters, and you can find a couple of these from time to time on eBay. The newer SDRs are going to run rings around those, but the selective level meters can be good for field strength measurements and a number of other things around the shack that can be useful at these frequencies. Now, average ham antennas that are used on 630 meters whenever you're evaluating your system. We get a lot of guys that are using HF dipoles, a 20 meter dipole, an 80 meter dipole, 160 meter dipole. These generally tend to work pretty well. Your mileage may vary depending on your noise situations. We get guys that are using unmatched random wire antennas. Again, you're back to the common mode issue. Are you going to have noise problems from things around you that you may or may not be able to control? We get a lot of guys that try what I refer to as dumb luck antennas. And we had a guy a couple of seasons ago that spent the entire season monitoring us using a Cushcraft A3 tribander sitting on a 50-foot tower. Was able to hear all of us really very well, and he had the added feature of improved signal to noise ratio because it wasn't a resonant system. Now, they weren't directive systems at all, so you're having to take pretty much what you get. But still, very good. You can have very good success with very simple antennas. Now, I will say this: there are no amateur antenna tuners or impedance matching networks on the market today that have the proper combination of L and C to be able to work at 472. Okay, so don't even go there with that. Just put it in bypass mode and you'll be in better shape. Now, some guys may have delta loops. Let's say a guy's got a 40 meter delta loop and he wants to listen with that. The actual inductance presented by that loop on, let's say, 40 meters, that's about 145, 150 feet of wire. Well, if you look at that with an analyzer, it still looks like a dead short at 472. And so you kind of have that same performance problem when you're trying to listen on antennas like that. And again, like all these other antennas, you really have to take what you can get in terms of noise. My recommendation for people using a loop like that would be to open up one side of the loop, the ground side of the loop, for example, at the antenna. So now it looks sort of like a bent wire that's just kind of floating out there, and that'll work much better than the closed loop at those frequencies. Okay, now, when you get a little more serious about this, your your antennas have a tendency to take up more acreage, they tend to get a little bigger, but they tend to perform better. And at the end of the day, improving your signal to noise is the name of the game, okay? And this is typically done through directivity. Now, many of us use beverages or beverage on grounds, which are basically beverage antennas that are laying on the ground to improve our signal to noise and actually attain some directivity. I'm not going to go into a lot of detail on these because Eric's presentation tomorrow will go into the very detail and theory on all of these, but I will go through and mention them. I'll tell you my opinion on the beverages are that at 630 meters, your 160 meter beverage is going to be too short, okay? But that doesn't mean you won't have an improvement on 630 meters. And Eric tomorrow will tell you about how his beverages actually perform, which actually do very well in terms of hearing. Now the K9AY loop is the shared apex loop is a product that's actually marketed by Array Solutions. It's a little pricey in my opinion, but people claim that it works as well as a beverage, and they do have a medium wave version available. It does use phasing lines, and it actually looks like a pair of loops, but people that have them seem to have very good success. Now the K9AY loop, this is a terminated loop antenna, and I actually have had very good success with this antenna on 160 meters, also to a certain degree on 472. The biggest issue with the K9AY loop is that it is a ground dependent antenna. So as ground conditions change, you're really forced into a situation where you have to make adjustments to the termination resistance to be able to compensate for changes so that you can maintain the pattern that you have. The nice thing about the K9AY loop is that it is scalable, and GW3UEP has a very nice commentary on taking your normal K9AY loop and increasing the height to something like 75 feet and really having a very nice capture area. Flags and pennants are in some ways similar to the K9AY loop, except they're ground independent. They're actually true terminated loops, and they tend to work very well if you have the room for them. Now, one antenna that I use at my station is the resonant multi-turn loop, and I'm going to come over here again and click on this. Now this antenna is essentially, really I added it to my arsenal a couple of years ago. It's essentially an LC network. You've got multi-turn inductance here. You've got a capacitor here that is in parallel that you resonate the entire thing at 472. There's an internal pickup wire that is separate from these wires that actually picks up the signal and feeds that back to coax via an isolation and step-up transformer. So you get really good control of your common mode in that particular case, and you have a tendency to avoid a lot of the trash that's running down the coax that can impact the pattern ultimately. What I like about this antenna, it is bidirectional, I should point that out, and I'm not typically a fan of bidirectional antennas, but what I do like about this antenna is that when there are storms that are moving across the Oklahoma, maybe Nebraska, Kansas, I can put the null on this and just follow them right across and still hear the stations that I want to hear around the country. And when you're dealing with an antenna like this, you really want to focus on nulling the noise sources, not peaking the signals, and that's where these have the greatest benefit. Also, the question I get from time to time is, with all the trees, can it actually turn? Yeah, this can turn 360 degrees in spite of the trees. I've actually got it in a pretty good. How high is that? It's probably about 10 to 12 feet at the top, and probably about a 7-foot wingspan across. Now, the high Z vertical arrays are actually very common these days on 80 and 160 meters. And there's actually been some work done to expand these for use at 472 by changing the phasing lines on them. And they tend to work pretty well. The real issue is the spacing between the elements. Now, the next one, the broadside in-fire 8-circle array, I'm only going to mention this briefly, but I'm going to let Eric talk about it tomorrow. This is actually his baby. It is actually the largest receive antenna in the world on 630 meters. It covers 30 acres. It sits in the woods, and he can essentially rotate the thing and hear basically what he wants. I don't think I've got time to give you one of the anecdotes about this. I'm just going to leave it and say that this is a very good option if you've got a lot of space and you want to hear anything and everything. Eric does a very, very nice job with his receiving. Now, the eProbe active antenna was a little bit of a surprise for me. As I mentioned earlier, my preference is antennas that are directive, where you can essentially null noise sources. But the eProbe active antenna is basically a very short probe coupled to a high gain amplifier. In fact, here's one right here. Now imagine being able to use this to listen from 10 megahertz to 10 kilohertz. It'd be really amazing. Well, that's exactly what that antenna does. And I have one hanging in the pecan tree in my front yard. And I've been very pleasantly surprised over the last year that I've used that antenna. Now, quick anecdote going back to the comments I made about the QSO with Merv and KH6 a few months ago. The night that we had made this SCAD, I had come into the shack, I had been asleep, whatnot, and came in and started tuning around trying to hear a signal on the receive antennas. I couldn't find one of my directional receive antennas that could actually hear him. Switched over to the eProbe antenna that's hanging in the pecan tree out front, and boom, there his signal was. It was just as loud as can be. We made the QSO, and there were no problems. Really, the take-home message here should be that you can never have too many receive antennas, and even the ones you think are probably not very good, they really tend to pay dividends. So moving on to transmit antennas, at these frequencies vertical polarization really is king, and a lot of this has to do with the fact that RF at these frequencies tends to power couple to the ionosphere much more efficiently when it's vertically polarized than it is for horizontal signals. You have the other aspect of a horizontal antenna shorting the E field with respect to ground, because you're never going to get the antenna high enough, which is one of the reasons you don't see a lot of guys running dipoles at these frequencies as well. Now, most of us are dealing with base and capacitively top-loaded verticals over large radial systems. Now, as you'll see, as you saw earlier, it didn't necessarily require a large radial system or a lot of top loading to find some degree of success. Yes, sir.
A way we found that was easy to visualize this when you're talking about capacitively loaded antennas, what you're actually dealing with, since it's so electrically short, is a great big open air tank circuit.
That's right.
The antenna is a plate of your capacitor.
That's right.
The radials at the bottom is a plate of your other plate of your capacitor.
That's right.
The coil is the coil in your tank circuit, and you're feeding this tank circuit, and then the RF circulates in this circuit.
That's right.
Here. Now, the closer down to the bottom you put things like the loading coil, the more coupling of your energy is to the ground, and you're going to have losses.
That's right.
But in any event, if you look at it as, instead of thinking of it just as an antenna, but think of it as a great big tank circuit sitting out in the air, then you can really visualize what's happening. That's a great way to say it. For the purposes of this presentation, we're going to focus on this particular kind of setup. Now, that said, vertically polarized loops are also very popular in areas where the ground conditions are actually fairly poor. You go into the Northeast, you've got a large number of guys that are running these large vertically polarized loops hung between trees. They're typically transformer coupled, and they're resonated with capacitors. Well, they don't necessarily have to be huge to be functional. In fact, here locally, there's been some work done by Jim Vole, WB5WPA, who operates as WH2XQC up in Allen. And he uses a variety of large capacitively resonated transformer coupled loop called the Edgington loop. And this is basically an antenna that will fit in a backyard. He's using some of the tent poles that you see. Clint W3ARS down in the flea market. He's got the tables of the green tent poles that basically Jim stacks these up on either side of his yard and strings this loop
between them, and running just a couple of watts TPO. Now we're not talking ERP or EIRP, we're talking total power output. He's been heard all over North America in that particular arrangement. A little bit of engineering would make this particular design rotatable. So imagine being able to use a single antenna for receive and transmit, and then be able to essentially focus your energy in two different directions, or through the plane of the, or through the ends of the antenna. So there are some possibilities there depending on what your particular situation is. Now, when dealing with transmit vertical antennas, there are a few priorities. First and foremost, tall as possible. This will essentially contribute to increased radiation resistance, which you want that to be as high as possible. Generally speaking, most of us are running anywhere from a half of an ohm to maybe an ohm of radiation resistance on these systems if we're lucky. We want lots of capacitive top loading, as much as you can get, as much as practical. If you're going to use if you're going to use loading coils, high Q loading coils are recommended. You put them at the bottom, put them at the top, wherever you want to put them. I'll explain why I put mine where it is in just a few moments. Ground system, particularly near the feed point, you need a good ground system. I can't overemphasize this fact. Ground losses are really going to be the dominant situation at these frequencies. Large diameter conductors, this is primarily for the vertical section of the antenna. Now, when I started playing on these frequencies, my first antenna was a wire vertical, a wire Marconi T. And one of the things that I found is that as weather changes occurred, I run close to 3 miles of radials under my antenna. I have 150, 100-foot radials sitting under this antenna. And even with those types of ground conditions, when the ground was wet, it would change pretty significantly, and I would have to reach for the motor control on the variometer in the shack and adjust so that I could compensate for those changes as a result of the wet conditions or the cold conditions or the icy conditions. I found that the system stabilized pretty significantly when I changed to 2.5-inch DX Engineering vertical pipe for the vertical section, and then hung the top loading off of that. I don't have nearly the impedance excursions that I had before I did that using simply the wire. So that's a very good option as well if you have problems with stability in your system. And that can be a real problem if you're running considerable amount of power and a switch mode amplifier, because those amplifiers don't like reactive loads. So if you go to bed with a match and you wake up in the morning and you've shifted a little bit, you may pop a FET and start a fire, and who knows what else could happen in your station. Any number of things could happen. So stability is really important.
Hey, John?
Yes, sir.
What was different? I mean, what changed when you used this 200?
I think probably the capacitance went up pretty significantly, and that ended up increasing the efficiency of the entire system. And I think that's probably what helped the entire system stabilize a little bit. High quality insulators, and I've mentioned fires, I've mentioned things like that. Use high quality insulators. You're dealing with extremely high voltage on these very short systems. If you've ever run 40 meters mobile with an amplifier, you probably have seen corona coming off the antenna if you don't have the ball on top. Well, imagine putting a few hundred watts into an antenna that's a 32nd of a wavelength high on the frequency you're operating on. And there are some cases where I may see up to 12,000 volts at the top of the coil at an appreciable current that is very much lethal. So you want to be careful and use high quality insulators. And I'll show you some pictures of guys that had crazy things happen with their insulators just a bit. Yes, sir?
One of the things we learned out on 1750 meters for the guys, one of the easiest ways to get started on this is the Marconi T, and you can do that with like an 80-meter dipole.
Yeah, we're going to cover that in a few minutes.
Coming down is your vertical,
Yeah.
and then your flat top is your capacitive.
Right.
What you can do if you can't invest in 150 radials down underneath, and that's a cheap way to get started, and you'll get a large percentage of the benefit, is chicken wire.
Yeah, that's right.
25-foot rolls of chicken wire, and run one this
That's
way,
right.
and one this way. If you want really, parallel to your top. If you want to really, be fancy, run two more this way, so you've got an X. It will give you a huge bunch of what you would get with all the radios.
Well, interestingly enough, the house I grew up with has 1,700 square feet of chicken wire in the background at the moment. So
Chemical grounds.
you can use chemical grounds. I would recommend that you use Epsom salt if you want to.
Buy it commercially from for almost nothing, like $10, $15 a.
What I would say about using Epsom salt is that it's just magnesium sulfate. It's not going to have an impact on your yard. It'll actually help your yard grow because it'll stimulate growth. Whereas if you use some of these other chemicals that are available, you may have an impact to your lawn if you end up doing it.
My well.
Pardon?
What's it going to do to my well?
Well, if you're going to mine it, I guess that remains to be seen. But at any rate, you can use chemical grounds. I would typically save chemical grounds for your station grounds and things like that, where you've got ground rods and fixed grounds. But if you want to spray your yard with Epsom salt, particularly if you're in a marshy area, that'll probably help you.
A pipe. You can buy a commercial thing.
Sure, it's got the holes in it. Yeah, sure.
Pipe, and you just pour the chemical into it. And,
well, and that'll actually work at these frequencies because the penetration depth of RF at these frequencies, at HF maybe 160 meters, if you're dealing with average ground conditions, the penetration depth may be a few inches to maybe a foot. At these frequencies may be measured at tens of feet depending on your ground conditions. So conceivably you very, very easily could help yourself in doing that.
Another thought is to put my ground in my leach field for my septic tank.
And that would be particularly if you went and threw a bag of Epsom salt out there and allow it to propagate. I would say that certainly wouldn't hurt. So anyway, moving on, antenna options, as the gentleman was mentioning the variety of antenna types. You can do your traditional inverted L. You can do your traditional top-loaded Marconi T with multiple wires and multiple feeders. This will accomplish the concept of having a fat conductor, if you will. One of the issues with this particular, or I should say one of the benefits of this particular issue is that because of the symmetry, in theory, you should see a top load that does not radiate. Whereas in this particular situation, you can see some asymmetry, and as a result end up seeing some radiation of the wires here. My personal opinion, my top load, I use a 100-foot and a 200-foot asymmetric top load, and the system, in doing that, I actually reduced my loading from by about half as a result. So in my opinion, it was actually worth it to go ahead and do that and not to worry too much about the radiation in those top loads. Another item that I want to talk about here, and really the reason I want to show you this slide is just if you're going to use these insulators, put two in series. You'll get all sorts of corrosion and air pollution and things that build up on insulator surfaces, and it'll get wet, and the next thing you know it's conducting, and now your antenna's laying in the yard because the rope or whatever burned up, and that's probably a good idea to use a couple of these in series. Also, your feed throughs. One of the things you see in the handbook, a lot of times they talk about the lead in through the window strip. Use a good quality insulator at these frequencies. Don't burn your house down doing this stuff, okay? I can't overstress that enough, and I'll show you some pictures here in a bit. Most of us have started fires at one point or another with our antenna system, and I know a lot of people laugh about that, but it's a serious thing because it's very possible at these frequencies using the voltages we're dealing with. Now,
how much power are you running here?
200 to 250 watts TPO at the moment. So Marconi T has been used for a long time by a lot of people that wanted to work 160 meters but maybe didn't have room for a 160 meter antenna. So they'd take their 80 meter dipole and feed it so that the feed line section was the vertical, again with essentially the dipole arms functioning as the top load. And that arrangement can work very well for 630 meters. I don't recommend you pulling that coax all the way into your shack and running your tuner that way, because you still have very high voltages existing on that coax that you're feeding, where both conductors of the coax are actually being fed with power. Your insulation on your coax is not going to be able to stand that off, I guarantee you. So the best way to do this is to have a loading coil somehow on the base, at the base of the antenna, maybe at ground level, fed against a rudimentary radial system. And I'll tell you that in my experiment a couple of years ago, using just whatever amateur antenna I had available, I took a G5RV, a half-size G5RV with a loading coil fed against 3 radials. Okay, they were, I don't know, they were 30 feet long with a ground rod. And again, keep in mind, I live in an area that has pretty good average ground conditions. And that antenna was only 6 or 9 dB down from my primary full-size antenna with all the top loading and all the radials. And basically I was hearing, or I was with digital modes, I was hearing and working the same guys that I would have been with the full-size antenna. And so the situation really can work very well for you if this is what you have available. One of the things you have to remember is to hang this antenna in free space. I've seen a lot of crazy things with guys using G5RVs and things like that where they've got the wires looped over branches or stuff. You will set that tree on fire. If you have twin lead wrapped around, you've got a G5RV and that section's too long, don't wrap it around that trunk. The tree's going to catch on fire. Okay, it needs to somehow hang in free space, or if you need to reorient that. And that's one of the reasons I have this second picture, is that this is really an option for you if you have too much feed line. Wrap it around an insulated support. And the only thing about this picture is Rudy Severin's N6LF did a lot of work that showed, don't worry about hanging extra dipole straight down. Okay, people a lot of times will worry about phase cancellation and things like that. In what you're doing here, you're better off having the extra top loading than you are worrying about whether or not you're going to cancel phase and whatnot. Okay, so moving right along very quickly, I'm going to skip this because we're short on time, I think. When we're dealing with these systems, the way we resonate them is with a variometer. I'll show you what a variometer is in just a moment. And typically you're going to use a match with either a shunt capacitance, a shunt inductance, a transformer. You could use an L network. There are a number of options to being able to accommodate that. In my particular system, and this is probably a picture from 2012, so quite a number of things have changed. I resonate my system using the bucket coil here. It's wound with wire, and it's in series with this internal coil that is turned over here. You don't see it in this particular picture, by an Archer antenna rotator, so I can adjust the actual resonant frequency from the shack itself while monitoring essentially what the impedance actually is. I actually match the resistive portion of the impedance to the coax via a shunt capacitance, and this has actually been replaced since then with motorized vacuum variables, so that I can essentially go anywhere from 460 to 490 and have a 50 ohm resistive match. And this is really the way to do it if you're looking to operate on this band. Now, a lot of people say base loading is really the wrong way to approach a vertical. Well, when you're dealing with an EIRP administered band, turn the power up. Okay, it's easier to turn the power up and run a little more power, taking advantage of the fact that you've got some of these losses, than it is to mechanically put a large coil very high on a vertical antenna. That can be all sorts of crazy to deal with when you're trying to actually raise the antenna up. Secondly, as I mentioned, most of us are using switch mode amplifiers, and the FETs do not like reactive loads. So being able to dynamically tune the antenna to the frequency you're operating at is extremely important. And so that's the reason I prefer this method. Not everyone agrees with that, and that's okay. You have to do what you want to do. I want to be able to work anywhere within the band, and that's essentially what I do, is that I can move anywhere within the band and match the thing to a 50 ohm coax.
How about a top load and top inductor?
You could do that, but now you
trim it with this.
But again, you could do that, but now you have the mechanical issue of raising the thing. Okay, and that can be
just a fixed coil up there.
I understand, but you have a coil that, because you got to remember that at the top of this vertical, this thing is sitting 80 feet in the air, so you've got this little 1/4 inch piece that's sticking up at the top that has these top wires that are hanging off of it. You start putting a lot of weight on that, that becomes really unmanageable. If I have a helicopter that I can fly the vertical in and set it down in situ and guy it, that's one thing. But if you're trying to raise that thing, if you were using the falling derrick method, I don't have that capability because I've got trees all around my antenna.
You've got a line between two trees and pulling the antenna up.
Yeah. So yeah, I mean there are possible.
An antenna can.
It does. Yes, it does. Yes, it does. Okay, so real quick, generating a signal, much like the receiving, K3 with a synthesizer, K3S, the Kenwood line, older ICOMs, newer ICOMs as well in many cases. I want to mention the older ICOM that's Mars and cap modifiable. Okay, a lot of these older rigs you can clip a diode or something like that, and they'll work anywhere you want to work on the band. I know someone that has had an old ICOM 725 that was modified, and it would generate about 15 watts at 472. Well, when we started looking at the actual signal, we found that there was about a half watt at 472 and about 14.5 watts of harmonic content in this. So the bottom line is, if you're going to do that approach, you need to have an outboard low-pass filter. Okay, that's very, very important. Now the other option, and this is one of the options that I use at my station, is the MF Solutions transmit down converter. This was developed by John Molnar WA3 ETD, who operates as WG2XKA. And he's one of our speakers tomorrow that's going to talk about generating power, generating signals, and making it radiate. He designed this based on the G3XBM version of the transmit down converter that basically takes a signal in either the 30 meter band or the 80 meter band and transforms that to 472 to 479 kilohertz through down conversion. Now, well, this particular unit with this IRF 510 will generate about 20-25 watts of clean power into a 50 ohm load. Now, it is running Class D, so it's not you're not going to run phone, you're not going to run PSK31. He also has options for receive, pass-through. He also has an outboard external oscillator option, so you don't have to use the crystal oscillator. This is actually the way that I do it on my primary system. I use a GPS disciplined oscillator, and this has a really good stability in my system. In fact, I'll tell you that my exciter is actually less stable than the actual system here. At any rate, there are some flyers for this unit. I think John has a show special of $70 on one of these boards. I've got two of them that he sent me if anyone wants to go wants to take one home today. Again, there's flyers sitting here on the projector table if anyone would like one, and I will have whatever stock I have left, I'll have them here tomorrow as well. Now, one of the ways that I generate my CW signal is through what's known as the GW3UEP Amplifier. And this is an amplifier that was developed by Raj, GW3UEP, based around the IRF 540. Now, I'm a real fanboy for this amplifier. I'll just tell you, it's extremely simple. It's extremely inexpensive to build if you'll build it yourself. And dig through your junk box. And there are a couple of modifications that really make it very good. It comes in two forms. There's the version that I use with the MF Solution transmit down converter. I actually use a pair of them, and I drive those into a combiner through an external low-pass filter for my digital mode work. But I actually have one that has waveform shaping for my CW keying, and this is actually a very good way to generate a click-free signal, a CW signal at 472 kilohertz, and I essentially key a pair of these amplifiers, much like I do with the MF Solutions transmit down converter via the combiner for between 200 225 watts. As far as I'm concerned, this is a very good amplifier for anybody that wants to get started at these frequencies and operating. I do build a couple for people. If you don't want to build for yourself, I'd much rather you build your own amplifier. That way you can learn about how to service it. If you don't want to build one yourself, there's a flyer on the other side of the projector over there for the amplifier that'll take a 0 dBm signal from your K3S and drive it to 100 watts. But again, I got to tell you up front, they require a matched 50 ohm load. So if you're used to running crazy loads on your antenna systems, and when I say crazy loads, 1.3 to 1 is a crazy load whenever you're dealing with these Class E amplifiers. They don't like reactive loads, and they like 50 ohms. So keep that in mind. But if you can satisfy that requirement, you'll be doing just great all over the band. Now, when you're generating a signal, again, I'm going to mention this again, safety first. And here's a picture that was sent to me by Joe, NU60, who operates as WH2X I can't remember his call sign. If I wasn't on the spot right now, I could tell you exactly what his call sign was. He lives in Northern California. He's using a 43-foot DX Engineering vertical. We've got Corona ring here. Didn't seem to help. He had a breakdown as a result of some salt spray apparently across the feed point, and it did in fact catch on fire, and was a pretty brilliant display according to him. Yes, yes. Here's another picture of the fire. Now, the way they resolved this, DX Engineering sent him a larger insulator, a much longer spacing. I think it's something on the order of 6 inches, and he also uses a rain shield to keep the spray off. Okay. Real quick, I'm going to talk about a couple of things that I think are helpful. The base current probe, a very good way to monitor the system health. I have a probe, basically a current transformer out at the ATU. You saw it in the picture earlier. That basically takes a small sample of current, sends it back to the shack, and I display it on a meter. And this allows me over the long term to make determinations about just how good are the conditions. You know, this time of year my base current tends to go down a little bit. It's dry. I've got lots of trees around that are acting as resistive loads to my RF. So if I want to maintain a certain level of ERP, I have to up the actual total power out.
It's like a toroid probe?
Yep. Single turn through it is actually the hot line going through it, and then I've got a certain turn ratio that's on. And this one actually came out of a broadcast ATU.
Delta.
It's a Bauer. It is a Bauer.
I
Yeah.
know Bauer too.
Yeah. Okay. So the next item on this list is the scope match. I don't believe in SWR meters, and because I didn't give you my treatise on SWR, I'm going to tell you right now, SWR is a worthless metric whenever you're trying to develop a system like this. Don't rely on SWR, because impedance is based on resistance and reactance, and reactance can go either way, either capacitive or inductive. And so the only way to really tune one of these systems up appropriately is with a tool called the scope match. Now the scope match basically samples output on the output side of my low pass filter as it's headed to the antenna. I've got current sensing, and I've got resistors here that are acting as the load. This is 3 150 ohm resistors in parallel for 50 ohms, and then I'm sampling some voltage using a capacitive divider network. Now, I output that to a 2-channel scope. The bottom waveform is current, the top waveform is voltage. And I don't know if they teach this anymore, but there used to be the old saying, Eli the Iceman. Eli, the spelling of Eli, E is voltage, I is current. So we say voltage leads current, it's inductive, L. And Iceman, we say current leads voltage, it's capacitive. Well, it's the same thing here with these waveforms. Whenever they're in phase, we know they're non-reactive. We're at the zero reactance point here in this particular case, because both of these are sitting on top of one another, or are basically on top of one another. When voltage leads current, it's inductive, and so the voltage waveform would be in front, so I know to either decrease the inductance or increase the capacitance. The magnitudes are what determine the actual resistive portion of the impedance. Now, if I have 2 equal magnitude waveforms, I know that based on my set point on my sensor, it's at 50 ohms. Okay, and typically whenever I watch these, both of these waveforms are superimposed on one another, so they look like a single waveform. If they don't look like a single waveform, I know I'm not at 50 ohms resistive. Okay, now whenever current is lower than voltage, I know that we're in a situation where the impedance, or the actual resistive portion of the impedance, is below 50 ohms. Whenever the voltage is above, has a larger magnitude than the current, then I know that I'm above 50 ohms. So that's basically how I make sure that I'm a 50 ohm resistive station, and my amplifiers are happy. Oh, what did I do there? I screwed up is what I did. Bear with me a second. All right, Impedance Analyzer, VNA. I highly recommend having a good analyzer to set up your system. I actually transcribed a modification for the MFJ 259B analyzer. If you search on MFJ 259, 630 meters, you'll see a modification that will allow it to work at 472 and even 137. My opinion on that instrument is that it is not a very accurate instrument. Okay, it'll get you in the ballpark, and as long as you accept that fact, it'll get you close, then you'll be just fine. If you're looking for a high reliability, highly accurate instrument, I recommend something like the Rig Expert AA30. I got one of these a while back to replace the MFJ after I had blown the diodes for the 9th time and spent the 9th hour of my life replacing them. I ended up with the AA30, and I've been extremely happy. It gives you the sign of the reactance. It's fantastic. And I also use that as part of my standard operating procedure of setting up the system after a major weather change. I'll go through and I'll just check it to make sure that the wind didn't break anything loose on top of the antenna or anything like that before I start looking at it with the scope match. Now, the final tool that I'll mention here, and this is actually the second to last slide, so we're almost done here. The ON4 KST chat/logger. Now, what this really represents is basically a chat room for us to make skids. Low band operators have been doing this for a long time on 80 and 160. Elaine, ON4 KST, set us up a chat so that we can basically kind of interact in real time. The email's generally not very reliable and certainly not very quick. So this gives us the ability to be able to communicate with one another and actually interact in real time to make skids. There's a portal on my website that will allow you to get into this if you're not familiar with the process. But this is a good place where if you have questions, there's always a guy hanging out that'll be able to help you. Now, what does the future hold? Part 97 implementation. That's really where we're at. We're almost there. But it's not our timetable to decide. We're really trying to create a mainstream band. In my opinion, we've already created a mainstream band by the amount of activity and the amount of varied activity. We have a large number of individuals that are still filing their Part 5 grants, and most of us that have them now are probably going to hang on to them even after we get the ham band. A lot of manufacturers are beginning to work on hardware and accessories for the station to work, and hopefully to make this a little easier to implement for the non-technical ham. I'm a paper chaser, so I'm looking forward to the awards program implementation. There's already been one that's been implemented. The Japanese Amateur Radio League has a couple of awards that if I were operating under Part 97 rules, I would qualify for 3 or 4 of them after this point. So I'm looking forward to that, and of course there are the public service applications. So I've gone through that rather quickly here at the very end to try to get everything in. Are there any questions?